here we go. It says write a formula for the input of a function. So what I want to talk about, and this is where we're going with this, is we're going to be doing inverses. So we're going to address this in just a second, but remember that the function we have an x value, that's the input, right? And where does it go? It goes into a function, and most of the time we label the function as f, right? And then it spits out an output, right? So you put the input in, it does math, right? The function is like a machine, it does a bunch of math and it spits out an output. Now the output we call y, but in an Algebra 2 class, we say the output is actually a function of x, f of x, okay? So this is just the function but now sometimes we'll have an output and that goes into the function, but it's a special type of function that we call, and this is what we call the inverse function. You guys remember that from Algebra 1? Inverse function. Okay. Now, in this particular case, for the inverse function, whatever the value you had from f of x, or whatever the y value is, that becomes the input. And then it spits out an output because the function, an inverse function, is still a function. It does some math. And then it spits out an output, and now the output is the original value for x. So now if I put some numbers to it, here's another way to look at it too. This is my domain, all the x values. What do we call the y values? Anybody remember? If x is domain, then what's y? Range. And then think of it like this. If I have an input value of the number 3, right? And I do some math, and it spits out the number 5. Well, f is the function. But then if I take that 5 and plug it into the inverse, it will give me 3. So the inverse undoes what was done from the original function. All right, that's what we're going to learn today. I just want this in your notes at the very beginning so you can so it'll make sense, because what we'll do is we're going to manipulate a bunch of equations and it might not make sense. Take your earbuds out, guys. Put your cell phones away, okay? So let's do that. So it says, let f of x equal 2x plus 3. Solve y for f of x for x. Then find the input when the output is -7. Okay? So let's do that. I'm going to say y equals 2x plus 3. So in the first step, you're going to sub in y for f of x. Okay, so here we had f of x, here we're going to put y. And then the next step, we're going to solve for x. Oh, wait. Yes. So then, let's do that. So I got to get x by itself. So the first thing I do is I subtract 3 from this side. I subtract 3 from this side. I don't know what y is, so we just leave it as y minus 3 is equal to, these two will, 3 minus 3 equals 0, right? 0 plus 2x is just 2x. Then I divide both sides by 2. And I get y minus 3 over 2, because these 2's will cancel. And when I say cancel, 2 divided by 2 is 1. 1 times x is just x. So that's the first part. Then the next step is when the output, well, what's the output value? Well, in most cases, it's y, or sometimes we'll call it f of x. It depends on how formal we want to be. So what I need to do now is oops, that's not how you spell let. Got ahead of myself. Let y equal negative 7. So then I plug it in. Negative 7 minus 3 all over 2 equals x. Well, negative 7 minus 3 is negative 10 divided by 2, or negative 5 equals x. Now, from that information, what we know is this. That I have a function where the domain, when x equals negative 5, goes into some function f and spits out the range y equals negative 7. But we did it backwards. Okay. Another way to write that would be is I have x equals negative 5 goes into some function. The function does some math, and it spits out an output value of y equals negative 7. Because the relationship between these functions are, this is the relationship. What we did is we manipulated that equation by solving for the other variable, and then plugged in the output value, and then determined what the input value should have been, right? Because the relationship is the same. That equal sign, it kind of binds the left-hand side to the right-hand side. And as long as we solve the equation properly, whatever I do on one side of the equal sign, I have to do on the other. It's really the same equation as long as I use all the equivalency properties, okay? So when the input is negative 5, we know the output is negative 7, okay? And honestly, we didn't need to solve for x to do that. We could have plugged it in here, and then we would have ended up manipulating all these things the same way, right? So anyways, that's that one. Let me leave it up there for just a second for you guys to finish writing everything down.